Same solar system, same sun, same raw materials, but somehow you end up with a tiny rocky ball on one side and a planet so big it could swallow 1,000 Earths on the other. How does that even happen? Take a look at our solar system. You've got these 4 small rocky planets close to the sun, then a belt of rocks, and then bam! 4 absolutely massive planets made mostly of gas and ice.
So what's actually different about these two types of planets? Why did they form so differently? And which kind is more common in the universe? Let's break it all down.
Here's a wild stat to start with. The gas giants in our solar system contain about 99% of the total mass of all planets combined. The rocky planets? They're basically cosmic crumbs by comparison. The reason these two types exist comes down to one thing: distance from the sun. Specifically, a boundary called the frost line. Everything about the difference between rocky and gas planets starts right there.
Alright, so what even makes a planet rocky? It comes down to structure. Rocky planets, also called terrestrial planets, have a solid surface, a dense metallic core, and layers in between. Rocky planets are mostly made of silicate minerals and iron. The 4 dominant elements are silicon, iron, oxygen, and magnesium. These are relatively heavy elements that stayed close to the sun after the solar wind blew the lighter stuff away.
Mercury is the smallest of the 4, just 4,879 kilometers in diameter. It has no atmosphere to swing wildly. During the day, it hits 430 degrees Celsius. At night, it drops to minus 180. Venus is almost exactly Earth's size, but it's a completely different story. Its thick carbon dioxide atmosphere creates a runaway greenhouse effect, pushing Saturn's temperature to 92 times what we have on Earth. Earth is the gold standard of rocky planets. Liquid water on the surface, an oxygen-rich atmosphere, a protective magnetic field, active tectonic plates recycling carbon, all 4 of these things working together to support life. Mars is the outermost rocky planet. It has the solar system's largest volcano, Olympus Mons, at 21.9 kilometers tall, and a canyon system called Valles Marineris that stretches as wide as the continental United States. Here's a quick comparison of all 4 rocky planets side by side. The thing that really stands out is how different they ended up despite all forming from similar material in the same neighborhood. So what makes a gas giant? The first thing to know is they're not just big balls of gas, they actually have layers. From outside in, a visible atmosphere, liquid hydrogen, metallic hydrogen, and a dense rocky icy core. That metallic hydrogen layer is wild. Under the crushing pressure inside Jupiter, hydrogen actually behaves like a metal. It conducts electricity, and that generates the most powerful magnetic field of any planet in the solar system.
Jupiter is the king. Its diameter is 139,820 kilometers, about 11 times Earth's mass. It's not just bigger than Earth, it's bigger than everything else in the solar system except the sun.
That swirling red storm you see on Jupiter? It's called the Great Red Spot, and it's been raging for at least 350 years, possibly much longer. The storm itself is roughly 1.3 times the diameter of Earth. It's slowly shrinking, but it's still massive.
Saturn is famous for those rings, and they deserve the hype. They're made of billions of ice and rock particles, ranging from microscopic grains to chunks the size of a house. They span up to 200.
Uranus is an ice giant, not a gas giant technically. It's made largely of water, methane, and ammonia ices, tilted outside at 98 degrees, and has the coldest planetary atmosphere in the solar system at minus 224 degrees Celsius. Neptune is the farthest planet, about 4.5 billion kilometers from the sun. It's another ice giant with wind speeds up to 2,100 kilometers per hour, making it the windiest planet in the solar system. Here's how all 4 stack up. Jupiter and Saturn are true gas giants. Uranus and Neptune are ice giants. All 4 are massive by terrestrial standards, but there's a lot of variety between them. It all comes back to the frost line, the distance from the sun where temperatures drop below about minus 150 degrees Celsius vol or freeze solid. Inside this line, only rock and metal survive. Outside it, there was ice too. Beyond the frost line, the amount of solid material available to build planets was dramatically higher. Estimates suggest maybe 4 or 5 times more than the inner solar system. That's why the outer planets could grow so large. Here's how Jupiter and Saturn formed, through a process called core accretion. First, a solid rocky and icy core built up, reaching at least 10 Earth masses. At that point, gravity became strong enough to capture the surrounding hydrogen and helium gas. Rocky planets stayed small for 2 reasons. Less material was available inside the frost line, and Jupiter's gravitational influence scattered much of what was left. Jupiter essentially put a ceiling on how big the rocky planets could ever get. Jupiter formed incredibly quickly, within about 3 to 5 million years of the sun's formation. The rocky planets took much longer, with Earth taking up to 100 million years to reach its final size. Jupiter also went on a road trip early in its history. It migrated inward toward the sun before Saturn's gravity scattered enormous amounts of material that would have otherwise built up the rocky planets. Here's a fun fact about density. Earth is about 5.5 grams per cubic centimeter. Saturn, just 0.69 grams per cubic centimeter. Saturn is actually less dense than water. If you had a bathtub big enough, it would float. The magnetic fields are also wildly different. Earth's magnetic field is strong enough to protect us from solar radiations. It extends about 7 million kilometers toward the sun. Moons are another major difference. Mercury and Venus have 0, Earth has 1, Mars has 2 times 9 to 5 seconds. The gravity of gas giants is so powerful that they've captured hundreds of orbiting bodies. Rocky planets have thin secondary atmospheres, some created by volcanic outgassing. Their atmosphere doesn't just surround the planet,
It basically is the planet.
Earth is the only rocky planet with active plate tectonics. Tectonic plates recycle carbon, keeping our atmosphere stable. This prevents a runaway greenhouse effect like on Venus.
Jupiter's massive gravity deflects comets and asteroids away from Earth. Nice work, Jupiter! You're keeping us safe. Without it, Earth would face far more frequent impacts.
Venus might be the most important cautionary tale in the solar system. It may have had liquid oceans for the first billion years of its existence. Then a runaway greenhouse effect took over. One leading theory for Saturn's rings is that a moon got too close to Saturn. When it crossed the Roche limit, tidal forces exceeded the moon's gravity and it was torn apart. The debris formed the rings we see today. Mars lost its atmosphere because of its smaller size. A smaller planet cools faster, so Mars's iron core solidified earlier than Earth's. And without a magnetic core, there's no magnetic field. Jupiter has the most spectacular aurora in the solar system, powered by a continuous stream of charged particles from its volcanic moon Io. These auroras are hundreds of times more energetic than Earth's northern lights. Uranus's extreme tilt creates some seriously weird seasons. Each pole gets 42 years of continuous sunlight followed by 42 years of complete darkness. Its full year is 84 Earth years long.
Neptune was discovered in 1846, not by scanning the sky, but by pure pulling on it. They calculated where a hidden planet must be and pointed a telescope. There it was. Here's something that shifts perspective. There may be more potentially habitable ocean worlds among the moons of gas giants than there are habitable rocky planets. Europa, Ganymede, Enceladus, and Titan all have liquid water beneath their surfaces. When astronomers started finding planets around other stars, they discovered something baffling. Massive gas Jupiters should be impossible according to their stars in just a few days. They forced scientists to rethink everything.
Round 1. Size.
Rocky planets are naturally limited in how big they can get because there's a finite amount of rock and metal in the inner solar system. Gas giants have no such limit. As long as there's gas to pull in, they keep growing.
Round 2. Surface. Rocky planets have actual solid surfaces. You could in theory land on Mercury, Venus, or Mars. Gas giants don't have a surface at all. If you fell into Jupiter, you just keep sinking through increasingly dense layers of gas and liquid.
Round 3. Moons. Rocky planets have very few. Earth has one. Mars has 2 tiny ones. Gas giants have enormous moon systems. Saturn alone has 146 confirmed moons and counting.
Round 4. Rings. All 4 gas giants have ring systems. Saturn's are the most spectacular, but Jupiter, Uranus, and Neptune all have rings too. Rocky planets? None of them have rings. The gravity just isn't there to maintain a stable ring system.
Round 5. Potential for life. Rocky planets clearly win for surface life. The total number of potentially habitable worlds in our solar system might actually favor the gas giant neighborhood.
When we look at exoplanets, it turns out super-Earths and mini-Neptunes, planets between rocky and gas giant size, are incredibly common. Our solar system might actually be unusual in not having one of these in-between planets. Could Jupiter have become a star? In theory, if it were about 80 times more massive, it would have enough gravity to ignite nuclear fusion and become a brown dwarf, a failed star. Jupiter is impressive, but it's still about 80 times short of that threshold.
The solar system actually needs both types. Gas giants act as gravitational shields, deflecting dangerous comets and asteroids. Rocky planets provide the surfaces where complex chemistry its balance. Looking at exoplanet data, our solar system might actually be unusual. Wow, super-Earths and mini-Neptunes dominate. Most systems have planets in rocky and gas giant that we don't have. We might be the odd ones out.
Here's one of the biggest mysteries about our solar system. There's a huge gap in planet sizes between Mars and Uranus. Most other planetary systems have something in that range. Did ours have super-Earths that were ejected early on? Scientists are still debating this. Gas giants can migrate. They don't always stay where they formed. Hot Jupiters we found around other stars almost certainly formed far out and migrated inward. Our own Jupiter and Saturn likely moved around significantly early in the solar system's history. The NICE model proposes the gas giants formed in compact orbits and migrated outward. This reshuffling sent asteroids crashing into the inner solar system, heavily cratering the moon.
In about 5 billion years, the Sun will expand into a red giant and the inner rocky planets will be directly threatened. Mercury and Venus will be engulfed. Earth or gas giants will survive. When we search for life in the universe, rocky planets and habitable zones are the obvious target. Life, at this comparison, has shown us that gas giant moons could be in a very different type of world than Earth.
Okay, quick recap. Rocky planets, solid surface, thin atmosphere, small size, inner solar system, few moons. Gas giants, no solid surface, mostly atmosphere, massive, outer solar system, lots of moons.
The single most important concept? The frost line. That invisible boundary determined everything. What kind of planet could form? Location was destiny.
Rocky planets and gas giants aren't competing types. They're complementary. The gas giants shaped and protected the inner solar system, while the rocky planets provided the stable environments where chemistry could get complex enough to produce life.
Next video, we're going deep on the Goldilocks zone, the specific range around a star where conditions could support liquid water on a planet's surface, and why Earth sits right in the sweet spot. If this video helped anything click into place, go ahead and subscribe. We cover space topics exactly like this every week. Hit the bell if you don't want to miss the next one. Drop a comment below. Which do you think is more impressive, rocky planets or gas giants? I'll see you in the next one.